Hi everybody, it's Grandad here again, and today what am I up to? Well, today I'm going to do a little bit more science with you, a little bit more chemistry. Now, I'm not a great expert at chemistry, I don't claim to be, but I find it interesting, and you're always learning something when you're doing science, and it interests me greatly, and I'm always quite amused by the various things that happen with chemistry sets. Now, I managed to get a hold of a very old chemistry set. It's in this box here. I'm hoping the camera's picking it up pretty good. But this chemistry set was brought out by Merit, that's the company that actually made it, in about early 60s, about 62 or something like that. And it's quite a comprehensive chemistry set. It's got a lot of chemicals and a lot of different supplies in it. In fact, it does 131 experiments, which is quite a lot. Now, I wanted to show you this box because it's interesting to see that on the front of this box there's a picture of a boy without any he's got a nice collar and tie on his shirt, but he's got no protective clothing on, and he's certainly not wearing any protective glasses. And the other thing you see is the fact that he's on his own. There's just the boy there. Now that's the thing that the same picture was on most of the Merit chemistry sets, but it's a very good chemistry set. I mean, I've taken out a lot of the chemicals now. I'll just show you the inside. There's a lot of pieces in there. This whole thing was full of chemicals, of which I've got a few left in there, and lots of spare test tubes and various bits and pieces that you need in chemistry. And so it was a very good chemistry set. And I picked this up at a car boot sale many years ago. I've had it about 30 years, and I never used it because obviously I wasn't doing so much in the chemistry line, but it interested me, so I bought it. Now, I've got here another chemistry set which I actually bought. Incidentally, you can still get this chemistry set if you go online on eBay, and I've seen them for sale, a good kit with all the bits and pieces in for about £45 English money. I don't know how much that is in dollars, but you can probably work it out. Now, this is a later chemistry set. I'm not sure of the company that actually made this one. Oh, Decker Toys I think it's called. And this chemistry set is quite good, but it only does 60 experiments. Now, you'll notice on this chemistry set there's a boy and a girl, which is interesting. The girl is actually doing the experiments, but you'll notice straight away that she's wearing goggles to protect her eyes, and she's got an apron on. Now, this is where health and safety sort of came in and said that you've got to show, especially children, if they were using chemicals, that they needed to protect themselves. And that's why it's interesting to see that the second box there contains some of the safety measures that they put into these chemistry sets, aprons and the goggles, and the fact that there's a girl doing chemistry, because back in the day they didn't think girls wanted to do chemistry, but of course girls do chemistry, they enjoy it, and they're probably better chemists than the men, to be honest, because they're more studious. Now, one of the things I'm going to do today with this little video, and I've got all my safety gear here, but I'm not going to be dealing with anything particularly nasty in this first little video, but what I've got here is a couple of beakers. They're empty at the moment, and I've got a couple of chemicals from this kit, and what I'm going to do is mix them up in a minute. And also what I've got here is from the chemistry set again, is the little files of various chemicals. Now, I've numbered them about 1 to 12 or something like that, 10 or 12 different chemicals, and each one is colourless. I chose them especially because there's no colour in them. I mean, some are a little bit cloudy and that one's a little bit green, but it's not terribly colourful. Now, when you're dealing with chemistry, one of the things that you learn quite early on is that you can identify chemicals, whether they're acids or alkalis or bases or whatever you want to deal with, by using stuff they call litmus paper to test the chemicals. Now, also, in addition to litmus paper, which you may be associated with, you can use liquids. And what I'm going to do today is to try a few different liquids with a couple of different types of liquid indicators. Because when you have things made up for testing the chemicals, they refer to them as litmus powders, or the things I've got here today. This one, the first one, is a sort of a blue purplish powder in here, and it's called Litmus Powder. And I'm going to mix that up in a minute in a little bit of distilled water. And this one, which was very unusual, I've never seen it before, but this is what they call logwood. Now this is used in the logwood chippings. Now this is actually wood off a tree, and it comes off trees from Belize, I believe. It's a special kind of tree that grows over there called logwood tree from Belize, and it has a very strong dye in it. And it's used in the dyeing process of various fabrics, when you want to dye fabrics. But it's also useful in chemistry as an indicator. Now, I've just forgotten to get my dibbler, so I'll just go and break off for a second. Sorry about that, but I forgot to get my little pipette here, which I'm going to use in a minute, so I forgot to get that out. So we'll get that out. Now what I'm going to do in these little Pyrex jars I've got here. Now, as I say, you never know quite what's going to happen in chemistry, so it's a good idea to pop the safety glasses on. Even though I'm not dealing with anything dangerous, it's a good idea to wear your safety gear, because then you get used to working with safety gear and it doesn't become a hindrance to you anymore, even when you're doing ordinary things. If you wear your safety gear, you get so used to wearing it that you don't even notice you've got it on, and therefore it makes it a lot easier. Now what I'm going to do, I'm going to start with the logwood. Now I've not got much of it, but I'm going to put the logwood into here. Now I haven't practiced, and I'm going to use all of it. There's not much left in there anyway, so I'm going to use all of it. Because when you've mixed this up, you can keep it and use it for various testing of chemicals. And therefore I'll store it in another bottle. Now in this furnace flask I've got some boiling water. And obviously when you're dealing with boiling water, it's safety, so you've got to... I've got my safety goggles on. And what I'm going to do is pour some of this boiling water into my logwood and see what happens. And straight away you can see, I hope you can see, the liquid has turned bright red from that logwood, and it's very dark. And I'll just leave that to steep a little bit. I'll give it a little stir. But what I've made there is a sort of a tea using that logwood, and it's produced this lovely red coloured liquid. I hope you can see that on camera. Now I've got that one that's red. Now this one is litmus powder, and the same way I'm going to open this little phial. I'm going to try and open it. As I say, I haven't practiced this, so I haven't cheated in any way. I'm having difficulty just getting this cork to release, because it's been in there 30 odd years probably, and it doesn't want to come out. Now I'll tip quite a good quantity of this litmus powder in. I won't use it all because there's quite a lot in there, but I'll get a quantity of it there. And once again I'll pour on some boiling water, and it's distilled water incidentally. Now this time, here we go, I've got some rather lovely purple solution, and it's very dark, so obviously I put plenty in there, enough to make the liquid go dark. I'll just pop the flask down there out of the way so it's not spoiling our experiment. Now these liquids are very hot now, and really I don't know whether you should let them cool down before I actually start experimenting with them. I'm not sure. I got them out of camera a little bit there. There's the two liquids. Now I'll bring in some of my test samples which I've put in here, and I don't know whether you'll notice, but on the top of each one I've got a little bit of tape and there's a number on there. Now that corresponds to a list I've got in this little notebook, because another thing you want to do when you're doing experiments is try to have a notebook handy and write down your results, because if you want to repeat the experiment, especially if you've discovered something interesting and you want to repeat it, you want to make sure you know what you did. So it's a good idea to write down what you did, how you mixed it, how much you used, etc, etc. Now I haven't done that because this is just a demonstration on litmus and the effect of it. If there is an effect, I'm not even sure there's going to be an effect. I hope there is. But what I've got here is various chemicals. Now I've got this one marked up at number 1, and according to my little pad there, number 1 is actually vinegar. Now I'll try different indicators, and for this one, just because there's no particular reason why I'm using this one, but I thought I'd try it with vinegar, which is acetic acid, and I'll put a little bit of my pink coloured, there's the litmus, into the vinegar and see what happens. Now that's rather interesting. The vinegar from a pink Logwood solution has changed colour to a sort of ambery yellowy colour. So that's interesting. Now I've only got these individual ones, so I can't test different ones, but it would be interesting to see what colour vinegar went using the other indicator, to see what colour it went. So now you'd write down, I'm not going to do it because I don't want to take up too much video with writing and doing, but you would write down that the acetic acid, which is vinegar, with logwood indicator turns yellow. So that's interesting. So now I've got another one, and this one happens to be number 10, because I didn't put these in any sort of order. Now let me just see on my chart here what I've got down for number 10. This is sodium carbonate. And again, it's a clear liquid. So let's see if there's any change. And this time I'll use the purple indicator. And as I say, I haven't tried any of this, so I don't know what's going to happen. Now, I don't know whether sodium carbonate isn't a particularly bit shaky, isn't a particularly reactive, and it's gone a little bit lighter, it's gone mauve, but it hasn't turned to any other colour. It's still pink. So obviously you'd write down that the purple indicator powder is sodium carbonate doesn't have any change. Now just for fun, I'll try a bit of logwood in here just to see whether it does make any difference. I mean, you can add the two together, but we'll just try it, see what happens. And it's turned a little bit darker maybe, but it hasn't changed the colour. It's gone a little bit pink, so it's taken on the colour of the logwood, but it hasn't changed dramatically. But that's interesting. And again, you'd make a note of that on your notes. Now this one is number 9, another clear liquid, which I've mixed up, and on here I've put, this is ammonia. Now this is a very smelly chemical and it fumes a lot. So let's try this one with our logwood. And we'll try squirting some of that in. Whoops. A little bit shaky. Now this one, I would say that has gone a sort of ambery colour. Again, I'm not sure that's picking it up on camera, but that to me has turned a really sort of amber colour in the logwood solution. It's certainly not the colour of a logwood, which was very red and pinky colour. It's turned now sort of an ambery golden colour. Put that in there. Now the next one to try, this is number 3. There's still some crystals in here, and maybe you need some heat to get these crystals to dissolve. Oh, I'm a bit shaky. Try my left hand. I'm just warming this test tube up in this hot litmus water. It's not getting on the chemicals, but I just thought it might warm it up and help to dissolve those crystals, which hasn't really worked, but anyway. Now this one is number 3. Now this one I think is alum. I wasn't quite sure because the packet I got out of wasn't labelled very well, but I believe this one to be alum. And we'll try alum. And we'll try our logwood again. And we'll just squirt that in. Now there we go. That alum has turned quite a bright yellow. Now that's interesting. From a clear liquid, adding a pink liquid, has produced a yellow liquid. So again, I'd write down that alum with logwood indicator turns yellow. It's quite a bright yellow. Now I got a couple more here, chemicals which I've stirred up. Now this one is number 5. It has dissolved, thank goodness. Now number 5 is just ordinary salt. This is household salt that you'd use, and that's sodium chloride. This is its proper chemical name. And we'll try this one with the purple indicator, and we'll just squirt some of that in. Now there's my cork. Interestingly enough, that's had no effect at all. I mean, it's a little bit diluted, but it's still purple, the same colour as it was with the... so that hasn't altered. Now again, you'd write that down and you could try it again using the logwood and see if there's a difference in colour there. There hasn't been in this case, and as I said, I haven't tested these, so I don't know that they're going to work in any way. Now this one I've got, which is number 6, it's a little bit cloudy, it's sort of murky, milky, got a little bit of colour to it, but not a lot. Now this is number 6, and on my list here, this is ferrous sulfate. Now this time I'll try the logwood again, which is pink, and look at that. That has turned it into a bright, well, I don't know what colour that is. Well, I'd say that's purple. A little bit of that logwood. I might put a little bit more. Let's turn that ferrous sulfate into a bright purple colour, or a dark purple. So again, you'd make a note of that and write it in your notes. Now the next one I've got, number 7, again it's a clear liquid, and number 7 is acetic acid. I think it's acetic. Can't even... acetic acid. So we'll try this one again. The logwood seems to work a little bit better as an indicator. Maybe the purple doesn't work so well. We'll try this again. And there we go. With the logwood, let's turn that acid to 7. Let's turn that acid yellow. Not very dark, but it's definitely a yellowy colour. So again, you write that in your notes, the colour you've obtained. Put that back in the little file here. And number 8. This one's quite a milky looking liquid. Let's have a look what number 8 is. Number 8 on my list. Now this is lemon juice. So I think this is citric acid. Now then, which one should we try this one? We'll try our purple indicator with this one. Wow, look at that. The purple indicator going into the lemon juice has turned it into a beautiful pink. In fact, it's very pink. Beautiful pink colour. So that's interesting. Again, we'd make a note of that. So in there, they don't show up so well in this little tray, but we've got purple, dark colour, almost black, amber and pink with those indicators. And in this one, we've got yellow, red and 2 different shades. That one's yellow in that little stand. So all those different colours have come about by mixing the logwood and the indicators. Now I've got 2 more here lying down on the bench because I hadn't got a holder for them. That's 8 and I've got another 2, so that makes 10. Now this one is marked up at number 4. Now this one is zinc chloride. Now let's see what colour, if any. I'm have difficulty getting this cork out. Out of my bottle. Let's see what colour we get with our logwood. And that's turned quite a nice colour. It's a different colour to the indicator. And I would say that that's amber. What a nice traffic light amber colour. Nice amber liquid from that, which I said was number 4, which is zinc chloride. Got a nice colour there. Now this is number 11. Again, a colourless liquid. And according to my chart, which is flipped over, this is hydrogen peroxide. Now that's quite an interesting, it's a form of bleach. Let's try this one with the logwood. And that one has turned again a nice yellow, ambery liquid. Using the pink, which it started as, plus the hydrogen peroxide, has turned that pink. Now it's a totally different colour to the one I had here. Hope you can see the difference in the colours. But they're totally different colours. Now that's very interesting. Now a lot of time you're dealing with chemicals, you want to, it's not always convenient to put liquids in your chemicals, because obviously once you put the liquid in, it's coloured it and you can't see it anymore. Now if I wanted to test with both these chemicals, I could use what they call litmus paper. Now I've got in this box here, I believe I've got, no, I've taken it back into the shed, so it's not there, but I've got some litmus paper. I'll just get it, it won't take a second, just hold on a second. Sorry about that. I'm sorry having to wait there, but I didn't get the litmus papers out. Now, what you can do is use litmus papers. Now, I've got a whole assortment of litmus papers here, which is why I wanted to show you them, and they're all different colours. Now, you can use those by just dipping them in to your chemical. And therefore you don't contaminate the chemical, you keep the chemical as it is, but you can get a test on it to see what colour it turns. Now, I'll just try one of these, I've got a green litmus paper here, and I'll just see, just for fun, one of these chemicals which had quite a strong reaction. Number 7 I'll try, which is Acetic Acid. Oh, the wind's blowing everything about, and let's blow my litmus paper away. And I'll just try it by dipping in the litmus paper. Now dip it in about halfway, and you can see there's an immediate reaction. From being green, it's turned into a brown by dipping it in. Now that's good because I haven't contaminated my liquid. The liquid is still the amber colour, but the litmus paper has turned brown. So that is another way of testing. Now I've got lots of litmus papers there, and I won't bore you with going all through them again, just showing the colours that you go to. But what I wanted to show you is that you've got a limited amount of litmus paper there, but you can actually make, using these two chemicals, your own litmus papers. Now what I've got in this little packet here are filter papers, which I use for filtering chemicals. But what you can do is get one of these filter papers and dip it in to your fluid, and it will turn the colour. And you can then, once you dry it, you leave it for a while, leave it in there for a while to go pink or purple, and then if you dry it, you will have a filter paper that'll be purple, and you can use that as a litmus paper. Cut it into strips like I was showing you there, and use it as a litmus paper. So I'm just going to put one in there, and another one in the logwood. And it hasn't coloured it quite so quickly, but I'm going to leave it in there in the hope that it will dye that litmus paper, that filter paper, and make for me some more universal indicator litmus. So that's quite interesting. So this little demonstration which I've showed you here is how to make indicators using logwood and litmus powders, and a few tests of various chemicals, and a little look at the chemistry sets which I bought, which I'm going to use. As I say, the one has got 131 experiments. Not all of them are that interesting, but I'm going to try and do as many as I can and bring them to you, because there's always something to be learned by experimentation. Now I'm not a great chemist and I don't know a great deal about it, so as usual I recommend that if you look at these experiments, which I'm going to do in the future and even the one today, look it up on other YouTube users and gain some more information, because I'm sure I haven't told you everything that's known about these particular things, and therefore there's more to be learned.